My name is Branko Kerkez. I'm a professor at the University of Michigan in the College of Engineering. I'm also CTO of a company called Hi-Fi where we make tech for flooding. Broadly, I work in the area of AI and water. So we're trying to figure out in this era of the self-driving car what it means to build self-driving water systems. So you could imagine one day that cities will be covered by measurement devices like sensors that are measuring the flow of water and soil moisture and rainfall, making predictions, and then making some sort of decisions to steer that flow of water in a way that wouldn't be done by conventional infrastructure. It helps to know how these systems are built traditionally. So right now, if you go on the internet and you search for flooding, it's very common to find events in real time. So not even something that happened last week or 2 weeks before. Flooding's happening constantly. And one of the challenges we have is our aging infrastructure. It was built over the last 100 years. These pipes are underneath the ground. Many of them haven't been seen for a really long time, so we don't even know what's going on necessarily. And so when it rains, this infrastructure is just completely overwhelmed, and it's difficult to keep pace with that because every time we build a new construction, it's expensive and it's just a piecemeal fix to the broader problem. And so what we do is we go in and we start off with measurements first. We build sensor networks. We partner with municipal managers, city managers, community groups. We put those out. We measure how the water flows, and once we understand how that happens is we build a model of the city to be able to do things like predictions. So one good example is if you can predict flooding 24 hours ahead of time, you can actually reduce the amount of damages by 30%. So to put that into context, city of Detroit flooded in 2014. One of the largest floods in the record in the U.S. Most people don't talk about it because it's not on the coasts, but that was $1 billion worth of damage. And so the ability to just tell people to move their cars to higher ground, to move their belongings to higher ground, just basic actions you can take within the first 24 hours for a very limited cost of just measuring and reporting can have a profound impact. And that's level one. And then we kind of go to the control portion, which I can talk about, I guess, if you're interested. There are two types of floods, and traditionally we tend to focus on one from a policy perspective more than the other. There are riverine floods and coastal floods, which means that the water levels near large bodies of water rise and cause flooding, and that's by all means a very bad thing when it happens. What we don't talk nearly as much as a second type of flooding called flash flooding. When it rains in a neighborhood that's not anywhere near a river, the pipes in the ground might be too small or clogged oftentimes because that's what happens. Just flood. And so that's where you see intersections flooded, parking lots flooded, neighborhoods flooded. And that's a lot of times where the loss of human life occurs. A lot of people misjudge how much water there is on the intersection or underneath a highway underpass, and they decide it's safe to drive. And that's usually one of the bad things that happens because it only takes about 18 inches of water to float a car. And so the discussion has been predominantly driven by large communities and rivers and coasts, because that's traditionally where the federal government has invested their measurement infrastructure. So measurements of water are typically done on big rivers, not in a parking lot where you can only see water once every while when it floods, as well as what we call floodplains. These big maps that describe where it's going to flood emanate from these large bodies of water, but that leaves a tremendous amount of communities out there that have to fend with flooding on a very, very frequent basis. And Detroit is just one example, but there's many inland communities that are dealing with flooding at a large scale, as well as just what some people call a nuisance scale, but it's very disruptive to their lives. You know, they might be going to work like 2 or 3 hours late, their basement might be flooded, and they just have to contend with that stuff. So it is a big issue, and it's a big issue across the whole entire country. A lot of the established ways to deal with flooding deal with new infrastructure construction. And you can look across the country and see examples of this, some of the largest construction projects on the record. So if you look at Chicago, they have what they call a deep tunnel project. It's hard to know how much it costs, but it's many millions of dollars because it took so long. Depending on the estimates, could be anywhere between $2 to $15 billion. It essentially means you're digging a big tunnel underneath the ground that's supposed to capture that flood water where it's flooding, which is oftentimes downtown or locations that are low-lying. It's a tremendous amount of money, and most communities cannot afford those kind of projects, even when scaled down to their size. And so oftentimes they just fix individual pieces one at a time, hoping that it's going to add up. They fix one neighborhood at a time, another neighborhood at a time, and hoping that it's going to reduce flooding. Infrastructure gets built on the scale of decades. And so we have a habit of just building something, coming back 50 years later and saying it's not working, let's build something else. Simply put, it's just too expensive. Most people can't afford it. With technology like sensors and data, it's a very low cost, high ROI effort to just get some sense of what's going on in the ground, right? Compared to billions of dollars investments paying a few $1,000s for measurements to be able to see what's going on, already gets you to be able to make better investments as you're going along. But then where the compounding value comes from is the ability to maybe change the flows of that water. So you take something as simple as a valve. Valves have existed for a very long time. It's not a groundbreaking breaking technology, but a valve connected to the internet and a valve that can be opened and closed in real time to move the flow of water. So for example, hey, it's raining a lot in my neighborhood and I have a retention basin in the back of an apartment complex. It's filling up. I need to let go of that water. Whereas another part of the system has capacity. Maybe you close that valve. And so these are some really simple things you can add for a very low cost that squeeze more performance out of your existing infrastructure. And again, going back to the estimates, squeeze so much performance out of it that it makes it seem in some cases as if it's like 2 to 4 times as large as it actually is. It's all about using the stuff that you have in a better way rather than just letting it all flow down and hoping it doesn't cause bad things to happen. A lot of these tech solutions are still relatively new, right? But we're getting to the point where we're just doing the same thing we've done for a very long time. It's just not yielding results. And so slowly some communities are getting around to trying new things, right? They can't play games with taxpayer money, but they can invest in the things that they see as tangible. So you can see examples in New Orleans where the city is building a large sensor network to just do these flood forecasts and be able to manage the flooding. It's already accepted it might flood, it will flood. So let's just get used to this kind of new reality and be able to respond better. And then you can go to places like Detroit where they're actively looking at digital technologies as a way to control their system. You have a system that's managed for millions of people. Many billions of gallons of storm water are moving through the system. And the idea here is rather than building a new tunnel, which might be cost prohibitive, if not impossible, you're investing into lower cost early on with the hope that you can squeeze more performance out of it. So I would say the investments are coming now out of a sense of it's time to try something new rather than necessity or maybe on the heels of an event that was really, really destructive, because these events come over and over and over again. And eventually the decision is made that, hey, we're going to try something different.